So we have section 6.1. We're going to be looking at multiplying and dividing rational expressions. So let's start by practicing how to simplify rational expressions. So if I look at the first example here, let's say we had x minus 3 over 3 minus x. And we're interested in seeing if this simplifies anymore. As you can see here, we have x minus 3, but here we have 3 minus x. So they look very, very similar. It just seems like we need to change the signs. So if you can notice that, then you can say, well, if we need to change the signs, remember, factoring a -1 will change all of your signs. So if I factor a -1 from the top, it's going to change all of my signs. So this is going to become -x, and this is going to become a +3. The reason we're doing that, because look what happens now. If we have -x plus 3, we can also rewrite it as +3 minus x. And now the top and the bottom match. We have 3 minus x on top and we have 3 minus x on bottom. When you're dealing with the fraction, if you have the same group on top and bottom, we can go ahead and cancel it. So this rational expression simply simplifies to -1. So if we have 2x squared over 10x cubed minus 2x squared, and we're trying to simplify, when we're simplifying rational expressions, you always have to completely factor before you can cancel anything out, or before you can see if anything factors. So the top, we have 2x squared. There's nothing we can really do with the top, so we simply write 2x squared. On the bottom, look, we're dealing with the 10 and we're dealing with the 2. You have to try to find the greatest common factor. Between 10 and 2, I see that they're both divisible by 2. Here I have an x cubed, here I have an x squared, so we can factor out, they both have in common the amount of x squared. So if we were to factor out 2x squared, so you think about 2 goes into 10 5 times. We took out x squared out of x cubed, so we took 2 x's out, so we're only left with 1. If everything happens to factor out, remember you have to replace it with a 1. Because if we multiply this back inside, we should be able to get back to the previous step. Now, it's completely factor, so now that it's completely factor, we can start saying if anything cancels out. We have 2x on top and 2x squared on the bottom. So there you can see if we have it on top and bottom, they can cancel out. If everything cancels out from the top, then that means we're left with 1. So we're left with 1 on top. On the bottom, we're left with 5x minus 1. So this rational expression simplifies to 1 over 5x minus 1. Let's look at 6y to the 4 minus 3y cubed over 3y cubed. So before you can simplify rational expressions, you have to completely factor the top and bottom. So if I look at the top, the greatest common factor between 6 and 3 is 3. The greatest common factor between y to the 4 and y cubed is going to be y cubed. So when I take out a 3, 3 times one number will give us back to 6, so I know 3 times 2. We took out 3 y's, so we're only left with one of them. If everything factors out, we have to replace it with a 1. So we over 3y cubed, we have 3y cubed on top and bottom, so we can go ahead and cancel those out. So if everything cancels on the bottom, then you're only left with 1, but do we really have to show 1 as a denominator? We don't have to show it. So we can simply say this simplifies into 2y minus 1. So go ahead and do this one. Go ahead and give it a try it on your own. If you have 6y minus 18 over 2y minus 6. And come back to the video after you complete this one. So we have to factor top and bottom. When we look at the top, I can see the 6 and 18 are both divisible by 6, so the greatest common factor is 6. And we factor out 6. 6 times what will give us back to 6 is simply going to be 1. we weren't able to factor any y's out because this doesn't have a y. This term doesn't have a y. So y stayed inside minus 6 times one number will give us back to 18, or you can think about 6 goes into 18 how many times, so it goes a total of 3 times. So that's how we factor the top. Now we look at the bottom. The bottom also have something in common. 2 and 6 are both divisible by 2, so they both factor in. A greatest common factor is 2. So when we factor out with 2 from here, we're only left with y. 2 times one number will give us back to 6, so we see we're left with minus 3. So we have y minus 3 on top and bottom, so they cancel each other out. So we're left with 6 on top, and we're left with 2 on the bottom. If your fraction continues to simplify, keep simplifying. 6 over 2 simplifies to 3. So this rational expression simply simplifies to just 3. Now let's look at 18 minus 2x squared over x squared minus 2x minus 3. So in order to simplify rational expressions, you have to completely factor. So we have to factor the top and we have to factor the bottom. When I look at the top, I see that we have an 18 and a 2x squared. So I know 18 and 2 are both divisible by 2, so we can factor out a 2. So when we factor out a 2, when we take the 2 out, we're left with 2 times 9 will give us back to 18. We took out the 2, so we're only left with x squared. And on the bottom, as you can see, because we have x squared minus 2x minus 3, it seems that we're going to have to be dealing with the AC method. In order to factor quadratic, you have to apply AC method. So we're going to go to the side here, and we're going to factor this out. So our a is 1, our c is negative 3, so a times c is negative 3. We're looking for factors of negative 3 that will add up to negative 2. So I know 3 and 1 will work. And my 3 has to be negative and my 1 has to be positive. Remember the shortcut, because a is 1, I know once I find my factors, it's going to factor into x minus 3 times x plus 1. Only because a is 1. And now I look at the top and bottom. It seems like nothing factors yet. Nothing cancels yet. So that means we might not be done factoring yet. So I look at the top. 9 is a perfect square, and x squared is also a perfect square. So we can recognize that that is the difference of squares. So differences of squares factor into the same group. The only thing that changes is the sign. So here, the number that's being squared is 3 squared will give us to 9. So this is going to factor into 3 and 3. Here, what we're squaring is x, so it's going to factor into 3 plus x and 3 minus x. So now we put it over x minus 3 and x plus 1. So you start to looking for anything that will cancel out. The only thing I see here is we have x minus 3 and we have 3 minus x. They're not exactly the same, but remember from the previous examples, we can get it to be the same, and you can choose to factor it out of anywhere. So I know my signs have to somehow change, and the way we can get it to change is by, this would be a 3 plus x. The way we can get our signs to change is to factor out a negative 1. So when we factor out a negative 1, this is going to become negative, and this is going to become a positive. So now I can rewrite this as, so we have 2 times 3 plus x times negative 1, because we factor a negative 1. I can rewrite it as x minus 3, and the reason why I'm rewriting it, just so you can see that now they're exactly matched. X minus 3 perfectly match. Nothing else cancels, so we're done simplifying. So I have a 2 and a negative 1. So 2 times negative 1 will give us negative 2. We have times 3 plus x over x plus 1. So that's our answer. That's how this rational expression simplifies. Let's do one more like this. So go ahead and example 6, x squared plus x minus 6 over 20 minus 5x squared. So pause the video and try this one. Based on what we did with example 5, give it a try for this one. So now we have to apply AC method to the top. So we have to apply AC method on the top. Our A is 1, our C is negative 6. 1 times negative 6 is negative 6. We're looking for factors of negative 6 that will add up to positive 1. So you can think about 3 times 2 gives us 6, but we want it to add up to positive 1. So that means my bigger one has to be positive and my smaller one has to be negative. Because our A is 1, we can take the shortcut and know that this is going to factor into x plus 3 and x minus 2. So we have completely factored the top. Now we look at the bottom. We have a 20 and 5x squared. So we look at the numbers. We have 20 and 5. They're both divisible by 5, so that means a 5 must factor out. So when we factor out 5, we're left with 4. And when we factor out the 5 here, we're only left with x squared. And nothing cancels yet, so that means we're not done yet. And the reason we're not done yet, because you should be able to recognize the 4 minus x squared is the differences of square, so we can continue to factor this one out. So differences of square factor into the same group. The only thing that changes is the signs. Here, we're looking for the number that when we square it gives us 4. So I know 2 squared is going to give me 4, so it factors into 2 and 2. Here, we're squaring the x, so I know it factors into x and x. So now we have x minus 2, and it seems like this one could match, but it doesn't look like it matches yet because the signs are opposite. So that means we're going to have to go up here. And if I factor a negative 1, it's going to change all of the signs of the x and negative 2. So I'm going to factor negative 1 to be able to match it with my bottom group. So now we have, you can rewrite it as x plus 3 times negative 1. I'm going to rewrite it as 2 minus x. So now you can see we have 2 minus x on top and we have 2 minus x on the bottom, so they're going to cancel out. So when we simplify this, we end up with negative 1 x plus 3 on top, and we're left with 5 times 2 plus x on the bottom. So when nothing else cancels out, we stop there, and that's our answer. So that's a little bit of practice of how to simplify rational expressions, because we're going to need that for this section. So now we can move on into actually multiplying rational expressions. So now that we're multiplying this, let's start with, I want to multiply 12x minus 8 over 49 times 14 over 2 minus 3x. So we have a rational expression being multiplied by another rational expression. So before you multiply this together, you need to completely factor. That's the key here. We need to completely factor, which is what we were doing on our simplification practice. So you have to look at this one and see if anything factors. I see that we have a 12 and an 8, so I can go ahead and factor it as 4. They have a 4 in common, so I factor out 4, so we're left with 3x minus 2. Times, we have 14 over, look, you can start looking to see similarities here. I have a 3x minus 2 after I factor out the 4. Here we have a 2 minus 3x. So they're the same thing. The only difference is the signs. So I can see that if I factor a -1 out of this one, it's going to change all of our signs. So this is going to become a positive 3x, and this is going to become a -2. So now that it's completely factored, now you can go ahead and multiply them. We have a fraction times another fraction. Remember the way we multiply fractions, we multiply straight across. So we have 4, 3x minus 2 times 14 all over 49 times -1 times 3x minus 2. Now that we multiply them together, we can see that 3x minus 2 and 3x minus 2 can cancel out. So from here, we end up with 4 times 14 on top, and we end up with 49 times -1 on the bottom. So 4 times 14, we end up with 56. 49 times -9, we end up with -49. And if your fraction simplifies, you need to go ahead and simplify it. So I see that this simplifies by 7, so they're both divisible by 7. So 7 goes into 56 8 times, and 7 goes into 49 7 times. And don't forget your negative. A lot of the times, if your negative ends up being in the bottom, that's okay, but a lot of the times we just like to throw the negative in the front. So when we multiply both of our rational expressions and simplify it, we end up with -8/7. So let's continue to practice more of the multiplication. If I have 1 plus 3n over 2n times 2n minus 4 over 3n squared minus 2n minus 1, and we're trying to multiply these rational expressions together. So start by, remember, you have to completely factor, so we have to start by factoring. So when we factor the top here, we don't have to factor anymore. There's nothing in common. We can't factor the bottom anymore, so we simply write 1 plus 3n over 2n. Now here we have a 2 in common. 2 is the greatest common factor, so we can factor out 2. And we factor out 2, we're left with n minus 2. Look at the bottom. The bottom, we have to apply AC method. So our A is 3 times our C is -1. We end up with -3. We're looking for factors of 3, so 3 and 1, they need to add up to -2, so I know it's -1 and +1. In this case, we can't take the shortcut we were doing before because look at your A value. Your A value is no longer a 1, so you do have to apply the whole steps of AC method. So that means I have 3n squared. My middle term is going to be replaced by minus 3n and positive 1n minus 1. So now we apply grouping, so we end up with 3n. Here they have a 3n and n in common, so we end up with 3n on the outside. We factor out 3n, so we're left with n minus 1. If they have nothing in common, we say they have a 1 in common, so we factor out 1. Factoring out 1 doesn't make a lot of change. They match, so it factors into n minus 1 and 3n plus 1. So we have to do a little bit of side work here. So I know this one factors into n minus 1 and 3n plus 1. Now we can go ahead and multiply it together. So when we multiply together, we are going to have 1 plus 3n here times 2 times n minus 2. And we're going to end up with 2n times n minus 1 times 3n plus 1. And now we need to cancel anything that cancels. So I have a 2 here. This 2 cancels with this 2. I also have 3n plus 1. And even though this one looks 1 plus 3n, remember how they're commutative? So if you think about it, you can always rewrite this one as 3n plus 1. So if we were to rewrite it as 3n plus 1, now they perfectly match, so they're also going to cancel out. So we're left with n minus 2 on top, over, on the bottom we were left with n times n minus 1. So that's our solution when we multiply these rational expressions. I have one more example of multiplication. So this was a challenging one. If you want to go ahead and try it on your own, go ahead and try it on your own. So we have x squared minus 6x minus 16 over 2x squared minus 128 times x squared plus 16x plus 64 all over 3x squared plus 30x plus 48. So before we can multiply our rational expressions, you have to completely factor. So you have to go ahead and factor everything the factors. So if you want to pause the video and go ahead and factor all of them, you can go ahead and factor all of them. You can see that we're going to have to apply AC method here, here, here. And on this one, it doesn't apply AC method, but we have 3 different AC methods we have to apply. So hopefully by now you already tried factoring this on your own. This one, when we apply AC method, we're looking for 1 times negative 16 gives us negative 16. We're looking for factors of negative 16 that will add up to negative 6. So 8 times 2, if we make a negative, negative 8 times 2 gives us negative 16. Negative 8 plus 2 will give us negative 6. Because a is 1, we can take the shortcut of x minus a and x plus 2. So it factors into whatever factors we found here. On the bottom, I can see that we have a 2 and a 128. They both have in common, they're both divisible by 2, so we can factor out the greatest common factor of 2. So when we do that, we're left with x squared minus 64. And here we apply AC method again, so we have 1 times 64 equals 64. We're looking for factors of 64 that will add up to 16. So 8 times 8 gives us 64. 8 plus 8 also add up to 16. And because a is 1, I can take the shortcut that it factors into x plus a times x plus a. Oh, look, if it factors into x plus a and x plus a, we learned this last week, this is actually a perfect square trinomial. So there you go. Now on the bottom here, you could have applied AC method just the way it is, or you could see that you have a 30, a 48, and a 3. They're all divisible by 3. So if you applied AC method, it's completely okay. If you didn't, here's a shortcut. You can take the greatest common factor of 3, and we're left with x squared plus 10x plus 16. And you just continue to factor. You cannot simplify until you're completely done factoring. So this one doesn't factor anymore, so we simply have x minus 8 times x plus 2 over 2. You can recognize this is the differences of square, so differences of square factor into x. This one is going to factor into 8 and x plus 8 times, this one doesn't factor anymore, so we have x plus 8 times x plus 8. Here, now we can just apply AC method to this part. So we have a is 1, c is 16, so we end up with 16. We're looking for factors of 16 that would eventually add up to our middle term of 10. So I think 8 times 2 gives us 16, 8 plus 2 gives us 10. So I know this is going to factor. Now my a is 1. So I can factor into x plus a and x plus 2. If the work I'm doing here is too little, make sure you're doing the whole work, whatever makes better sense to you, and double check that you're getting the correct factorization. Now that everything's completely factored, now we're able to multiply. So we multiply fractions straight across. So we have x minus a times x plus 2 times x plus a times another x plus a. All over, we end up with 2 times x minus a times x plus a times 3 times x plus a times x plus 2. Now we're able to start simplifying. This x minus a cancels with this x minus a. This x plus 2 cancels with this x plus 2. X plus a cancels with x plus a, and x plus a cancels with x plus a. Look how nice. Everything cancels on top. If everything cancels on top, we're just left with 1. On the bottom, we're just left with 2 and 3. 2 times 3 will give us 6. So this whole ugly thing simplifies to 1 over 6. So now let's move on to dividing our rational expressions. So if we're dividing rational expressions, if we have 8m squared over 3m squared minus 12 divided by 40 over 2 minus m. So we have a fraction divided by another fraction. Here's the thing. We can't really just straight divide it like that. So the way you do it is you switch it to a multiplication. So we take 8m squared over 3m squared minus 12, and we switch it to a multiplication. How can we switch it to a multiplication? In order for us to multiply, we take our second fraction and we flip it. So we're going to take 40 over 2 minus m, and we're going to flip it. So when we flip it, 2 minus m comes on top, and 40 comes on the bottom. Let me say that one more time. Division of rational expressions are changed to a multiplication, but you have to take the reciprocal, so you have to flip your second fraction, whatever fraction we're dividing by. Now we know exactly how to do this because we were doing it right before this one. So now we know we need to factor, if anything factors. am squared doesn't factor anymore. Here they're both divisible by 3, so if 3 comes on the outside, and we're left with m squared minus 4 times 2 minus m over 40. I can see this one can continue to simplify, continue to factor, so it factors into, I recognize it as the differences of square, so it factors into m minus 2 and m plus 2 times 2 minus, as you can see, we have a 2 minus m, but here we have an n minus 2. So if you want to go ahead and notice that right away, you can see that we need to change the signs here. So I'm going to go ahead and factor a negative 1. So when I factor a negative 1, this is going to become a negative 2, and this is going to become a positive m. 40 on the bottom. So now we're able to multiply together. So we have 8m squared times negative 1. I'm going to go ahead and rewrite this as positive m, negative 2, all over. We have 3n minus 2, m plus 2 times 40. And you can see that now n minus 2 matches with n minus 2, so we can cancel this out here. And then from here, we end up with negative 8m squared, because we take the negative 1 and multiply it by a, over, we have 3 times 40. So you can multiply your 3 times 40, or you can leave it like that. But if you multiply 3 times 40, we end up with 120 times m plus 2. And I have 8 and 120, so you always have to leave it in the simplest form. So I'm trying to see if this one's simplify anymore. So you have to find a common divisor among both of them. So they're both divisible by a. So a goes into a one time. A goes into 120 15 different times. So it simplifies into negative 1m squared over 15 times m plus 2. If you didn't write the 1 here, you simply wrote negative m squared. That's totally fine. And that's your answer here. So the only thing you knew we're doing is we have to switch it to a multiplication and you have to flip your fraction. Other than that, we've been practicing this already. So I have one more example for this section and we'll be done. So let's go ahead and divide 18y squared plus 9y minus 2 over 24y squared minus 10y plus 1 divided by 3y squared plus 17y plus 10 over 8y squared plus 18y minus 5. So we're going straight into a big example. So the first step is we have to change it to a multiplication. So we take our first rational expression times, when we change it to a multiplication, we have to take the reciprocal. So you take your second one and you have to flip it. So the bottom becomes your top. So we have 8y squared plus 18y minus 5 over 3y squared plus 17y over 10. So don't forget to flip it. Now you can see that we're going to end up having to apply AC method to all of them. So I will let you apply AC method to all of them on your own. So you can go ahead and pause the video, apply AC method to all of them, and then come back and we'll finish it up. Okay, so hopefully by now you applied AC to all of them. You apply your AC method. So this one actually factors into 6y minus 1 times 3y plus 2 over, this one factors into 6y minus 1 and 4y minus 1 times, this one factored into 4y minus 1 times 2y plus 5 over 3y plus 2 times y plus 5. So notice that I did skip the AC method part, but you have to show the work. Make sure you're showing that work. So you should have gotten to this point. Now that it's completely factored, now we're able to multiply together. So we have 6y minus 1 times 3y plus 2 times 4y minus 1 times 2y plus 5 all over, now we multiply the bottom. So we have 6y minus 1, 4y minus 1 times 3y plus 2 times y plus 5. And from here, now we're start to simplify. So we see that we have 6y minus 1 here, can cancel with 6 minus y. 3y plus 2 also cancels with 3y plus 2. We have 4y minus 1 cancels 4y minus 1. These ones are not like, they're not like terms, right? So they cannot cancel. So we're done canceling everything we need to cancel. So as you can see on top, we're left with 2y plus 5. And the bottom, we're left with y plus 5. So that's our solution here. So now you should be able to complete your homework for this section.